On the morning of December 31st, the silence around 3i Atlas broke again, but this time not with a signal, a flare, or a flash. It broke with a realization that what we're observing is no longer just rare, it's rewriting the framework we've used to describe space objects for over a century. It began with the orbital models, broken, then the energy math, violated, the spectral behavior, light response, motion vector, tail mechanics, jet angles. One by one, the rules started falling. Not one law, not two, but 9 foundational physical expectations surrounding mass, motion, energy, radiation, and time, all bent or erased, and no one at NASA has an answer. Let's begin. There's something unsettling about the way 3i Atlas reflects light. At first, it seemed like an observational glitch. A few outlier data points, nothing more. But as more instruments across the globe turned toward it, from Earth-based observatories to orbital telescopes, that anomaly didn't disappear. It became louder, sharper, more deliberate. Natural objects in space aren't supposed to reflect light like this, especially not comets. Their surfaces are irregular, porous, covered in regolith, a rough mix of dust and frozen volatiles that scatter sunlight in random directions. When light hits them, it diffuses, it smears, it radiates outward in a chaotic blur. But not here. 3i Atlas isn't smearing anything, it's bouncing light back with unnatural precision. Specular reflection, a term normally reserved for mirrors, metals, or artificially smooth surfaces, began to appear in the data. The reflection wasn't wide, it wasn't ambient, it was tight, directional, controlled. It gave the object an edge, not visually but mathematically. The light response pattern was angular, meaningful, almost engineered. Polarimetric data confirmed what the early visual hints had suggested. The light from 3i Atlas was negatively polarized at certain angles, a condition that only occurs when photons are reflected in a highly ordered way. Most dusty or icy surfaces scatter light randomly, creating positive polarization. But here, the polarization curve bent in the opposite direction, sharply and briefly. The same phenomenon was once recorded with Oumuamua, and now we're seeing it again. Negative polarization at these intensities implies an unusually smooth or compact surface, something that isn't covered in loose dust, something that isn't scattering light diffusely. Instead, it's acting like a dense object with flat facets, or even curved ones, that redirect sunlight coherently. And it's not just one reading. Multiple observatories recorded the same data. Independent teams, different instruments, consistent outcomes. What's even more peculiar is when the effect appeared, and when it didn't. The peak reflectivity happened in a narrow band of time, during a window when 3i Atlas passed through a region of space receiving a near-direct angle of solar illumination. That in itself isn't unusual, but the way the light responded was. Rather than slowly increasing brightness like a natural object warming up, the rise was sharp, almost instantaneous. And then, just as suddenly it faded. It was as if a surface panel had turned. Not a literal panel, of course, but something in the object's geometry, its structure, its layering, shifted or exposed a more reflective region. Not permanently, just long enough to create a surge of directional light. Instruments caught it, recorded it, and then it was gone. No comet in recorded history has exhibited this kind of reflection curve. No known asteroid, no known interstellar object, not even among the thousands catalogued by wide sky surveys. That silence in the archives is telling, because what we're seeing with 3i Atlas doesn't fit, not just statistically, physically. If this were a rough tumbling rock from another star system, we'd expect variance in light. We'd expect scattered reflection, changing patterns, dusty gradients. What we wouldn't expect is mirror logic, angular light response, temporal coherence. And yet, that's exactly what we have. No one's calling it artificial, not out loud, not yet. But in the quiet corners of astrophysics circles, the term structured geometry has started to circulate. Not confirmed, not declared, just whispered. Because when an object reflects sunlight like a sail, and not like a snowball, you have to ask what kind of surface you're really seeing, and whether someone, or something, designed it to reflect that way. Tales are simple, at least they used to be. In every textbook, In every undergraduate astronomy course, the explanation is consistent. A comet's tail forms as solar radiation pushes volatile particles away from its nucleus. It's sunlight, solar wind, and motion. Three forces that shape the classic image we've known for centuries. The tail always flows in the opposite direction of the sun. It doesn't care where the comet is going, it cares where the sun is. That's the rule. But 3 Atlas is ignoring it. As early as mid-October, astronomers began noticing inconsistencies in the tail's orientation. Images taken from different hemispheres, both ground-based and orbital, showed something unsettling. The primary tail did not consistently point away from the sun. In fact, at several critical observational windows, it appeared to bend toward it. Even worse, a second, dimmer appendage emerged from the object's forward-facing hemisphere. It didn't drift, it didn't trail, it pushed, directly sunward. It was dubbed an anti-tail, but even that term doesn't capture what it's doing. In comet science, an anti-tail isn't new. Under specific geometric conditions, usually involving the Earth's position in relation to the comet's orbital plane, you can witness dust particles forming what looks like a backward spike, pointing toward the sun. But that's an illusion, a trick of perspective. Those particles aren't being pushed sunward. They were ejected earlier and are now lying in the plane of orbit, catching light in a way that mimics a reversal. When Earth's angle shifts, the illusion fades, but this one hasn't faded. The anti-tail on 3I Atlas has persisted across several weeks of changing geometry. Observatories that should have lost the angle continued to detect it. The structure remained. The orientation didn't shift the way it should have. From 3 separate locations on Earth and 1 orbital platform, the same thing was confirmed. This was no optical mirage. It was material, real, dense, sustained, and moving toward the sun. And that breaks everything. The tail defied radiation pressure models. If it were dust, it should scatter away from solar influence. If it were gas, it should fluoresce in UV and bend sharply under wind pressure. But this tail curved gently, like it was immune. And the anti-tail? It didn't just glow, it pulsed. Not enough for the naked eye, but enough to show rhythmic density changes in stacked image exposures. Material flowed not away from heat, but into it. To understand why this matters, you have to go back to first principles. Heat drives sublimation. Sublimation creates jets. Jets push material away from the sun, and solar wind takes over from there. That's comet behavior. That's how we've explained hundreds of observed cases. And yet here, the system behaves differently. One hypothesis emerged. Uncomfortable, but unavoidable. What if the tail isn't reactive? What if it's active? The concept of an object using solar proximity not as something to survive but something to engage with is alien to standard astrophysics. And yet, that's exactly what this behavior resembles. A system that directs mass toward its power source. Not to cool, but to convert. In spaceflight terms, that's thrust. Controlled mass ejection in a direction opposite to the one you want to move. And when you align that mass ejection with the sun, the result is solar escape. In simpler terms, it's not just resisting gravity, it's using it. Traditional comet behavior doesn't include thrust, it doesn't include targeting, and it certainly doesn't include anti-solar emission that persists across changing geometries and maintains directional integrity. But 3I Atlas is doing all of that, and it's still not slowing down. The moment it appeared in the high-resolution images, astronomers paused. They'd been tracking the now infamous anti-tail, already confused by the way it refused to follow the laws of solar wind. But this was something else. Not a tail, not a drift, a jet. And it wasn't emerging from the night side of 3I Atlas, or from the neutral limb between sunlit and dark. It was erupting from the day side, the sun-facing side, and it was aimed straight into the heat. This wasn't just improbable, it was thermodynamically impossible. In every known case of cometary behavior, jets form in response to solar heating. Volatiles trapped beneath the surface, typically water ice, carbon monoxide or carbon dioxide, absorb solar energy and sublimate, transitioning from solid to gas. That gas then erupts through weak points in the surface, carrying dust and debris with it. The jets shoot outward, away from the sun, because the heat input comes from the solar side, and the only way out is through regions of lower pressure, typically on the night-facing side or at angles offset from direct sunlight. That's the model, that's the physics. But 3I Atlas violated it in one clean, stunning vector. The jet was observed erupting into the direction of solar radiation, not just perpendicular, not just misaligned, directly forward, aligned almost exactly with the solar vector, the one place no natural vent should ever point, because under normal conditions gas doesn't erupt toward the heat source, it escapes it, it flees into vacuum. But this jet advanced into the fire. The most immediate question wasn't about composition or structure, it was about why it didn't explode. An ice-rich surface venting material directly into solar flux should experience intense surface stress, the kind that cracks the crust or fragments the nucleus. But 3I Atlas showed no signs of fragmentation, no structural wobble, no drop in brightness. It simply ejected. Multiple observatories recorded the event. The European Southern Observatory first confirmed the vector, an estimated 107 degrees in relation to the solar direction. NASA's IR instruments picked up increased outgassing temperatures, but again, not from the shaded side. The ejection was happening where it shouldn't, where thermal pressure should prevent it entirely. And that raised a deeper question. Was this really sublimation? Sublimation, the natural conversion of ice to gas, is chaotic. The gas escapes quickly, unevenly, and at a rate tied to surface temperature. But this jet was smooth, linear, sustained over hours, not seconds. Its brightness didn't spike randomly. It pulsed, like a controlled exhaust. The energy budget didn't close either. For a jet of this intensity, the object would need to be absorbing immense solar input. But thermal readings showed the opposite. 3I Atlas was running cold. Its sunlit hemisphere stayed dozens of degrees cooler than models predicted. So where was the energy coming from? What powered this outburst? That's when the language around the jet started to shift. Instead of venting, researchers began using the word vector. Instead of subsurface pocket, they floated terms like directed emission. And instead of random outgassing, some quietly suggested a propulsion profile, not because they wanted to, but because nothing else fit. If this was a jet, then it wasn't just misaligned, it was weaponized. Not as a tool of destruction, but of movement. A stabilizing thrust timed with perihelion, allowing the object to respond rather than simply react. There's a concept in propulsion engineering known as reaction mass. You eject material in one direction to move in the other. It's Newton's third law, applied deliberately. Every spacecraft from Voyager to Starlink depends on it, and now something interstellar might be doing it too. The only problem? Comets don't apply force like that, unless they're not just comets. It didn't explode, it didn't wobble, it didn't flare or fracture or display any chaotic instability. It just shifted, cleanly, quietly, without visible cause. The change in trajectory was small, a deviation that wouldn't even register on a casual orbit visualization. But for astrophysicists watching 3I Atlas, it was seismic. Because the motion violated the one thing that governs everything in space, Newtonian predictability. When the first positional anomalies began to appear in early December, mission control teams from 3 agencies, NASA's Jet Propulsion Laboratory, the European Space Agency's Solar Dynamics Unit, and the Canada-France-Hawaii Telescope Consortium, quietly began rerunning orbital solutions. What they saw wasn't dramatic, but it was consistent, a steady divergence from the predicted hyperbolic path. The object wasn't where it was supposed to be, not dramatically, not dangerously, just enough to force the models to break. And the most important part? There was no visible reason. Most deviations of this kind can be traced back to a familiar source: outgassing. As sunlight heats a comet's surface, trapped gases erupt. Those mini-jets push back against the nucleus, creating small but measurable accelerations. Over time, those accelerations shift an object's path. The process is noisy, uneven, and produces rotational drift, all observable from the ground. But 3I Atlas didn't behave that way. The deviation wasn't chaotic, it was smooth, a precise arc like a sail catching a gust of wind. A soft curve away from solar center, as if it had made a decision. Even stranger was the timing. The acceleration began almost exactly as 3I Atlas passed perihelion, its closest approach to the Sun. This was the moment of peak radiation, peak gravity, peak thermal stress. It should have been the least stable moment in its entire solar trajectory, and yet it was here, not before, not after, that the object moved with the greatest coherence. Scientists measured the change in heliocentric velocity, only a few meters per second, but enough to matter. When plotted against time, the velocity curve didn't show the randomness typical of gas-jet dynamics. Instead, it formed a perfect bell: a rise, a plateau, a decline, acceleration, maintenance, deceleration, a thrust profile. That doesn't happen in nature. NASA flagged the event as a non-gravitational perturbation. The term is intentionally broad, a placeholder for anything that moves an object without invoking mass or celestial bodies. Historically, it's been used to describe gas jets, rotational mass loss, or thermal radiation recoil. But none of those explanations fit the shape or timing of this shift, and most importantly, none of those can occur without side effects. A jet that pushes should torque. A torque that turns should wobble. A wobble should show up in brightness curves, in coma shape, in tail drift. But none of those things happened. 3 Atlas remained steady, both structurally and optically, even as it moved off course. So, if it didn't push itself, what did? The only model that matched the trajectory data was one used in advanced orbital engineering: solar radiation acceleration. Specifically, the behavior of objects with extremely high reflectivity, solar sails, structures that convert photon pressure directly into motion. In that model, the curvature matched, the velocity profile matched, the temporal decay matched. But for that to be true, the surface reflectivity of 3I Atlas would need to exceed 90%, and it would need to maintain structural integrity across tens of thousands of kilometers, without fragmentation, without deformation. No known natural object does that, which leaves only two possibilities. Either the surface of 3 Atlas is composed of materials and geometry that perfectly mimic an engineered sail, or we're seeing an actual sail, and we've been watching it adjust course in real time. It's one of the most basic equations in physics. The more sunlight something absorbs, the more heat it emits. In space, where there's no atmosphere to buffer or spread that heat, objects tend to show this relationship with extreme clarity. Near the Sun, surface temperatures rise rapidly. Comets in particular respond with violent eruptions. Their icy crusts fracture. Volatile gases burst outward, and fragments scatter as thermal stress tears through their structure. But 3 Atlas refused to play by those rules. At 1.4 astronomical units from the Sun, well within the range of severe solar exposure, it should have begun to disintegrate, not catastrophically, but observably. Heat at that distance, without shielding or atmosphere, can push small bodies beyond their structural limits. At a minimum, it should have glowed from the absorbed energy. It should have radiated, it should have burned, but instead it glowed and stayed cold. Not in visual terms. The object brightened, yes, and its albedo temporarily spiked. But when astronomers turned infrared instruments toward it, the thermal signature didn't match. It wasn't heating up the way it should have. Spectral readings across multiple observatories revealed a temperature that stayed well below the modelled baseline. Even under direct solar irradiation, 3 Atlas maintained a cool profile. It reflected light. It emitted almost none. One by one, models fell apart. Thermal emission curves, which usually track an object's blackbody behavior, showed a suppressed peak, as if energy was being reflected rather than absorbed. That made no sense for an icy object covered in dust and volatile matter. Typical comet surfaces are dark and granular. They soak up solar energy and convert it to heat. But this object rejected the heat and kept the light. It glowed in visible spectra while staying nearly inert in thermal wavelengths. The question quickly shifted from why is it cold to how is it cold? The first hypothesis involved emissivity, the ability of a surface to radiate heat. A perfectly reflective object with near zero emissivity could, in theory, absorb very little energy, but those materials are usually engineered. Polished metals, carbon foils, dielectric mirrors, not ice and dust, not comet rock. The second theory looked at surface shielding. Perhaps the nucleus was covered in a highly reflective crust, a shell formed by centuries of cosmic ray bombardment. Over time, interstellar objects can develop a layer of hardened carbon or silica that behaves differently from the underlying material. But even then, the insulation effect wouldn't be enough to suppress heat to the levels being observed. And then came the most controversial idea: active thermal management. In spacecraft design, engineers often build systems that reject heat using radiators, panels, and phase change materials. These systems can balance input and output with surprising efficiency. If, and it's a dangerous if, something aboard 3i Atlas was actively redirecting or dispersing solar energy, that could explain the anomaly. But comets don't have systems. They don't manage energy. They endure it. They respond passively, not strategically. So how do we explain an object that brightens like it's absorbing power, but cools like it's rejecting it? In one frame of reference, it looks like camouflage, a way to appear brilliant in visible light while staying invisible in infrared. In another, it looks like efficiency, an energy collection method that avoids the chaos of heat buildup. In both, it resembles something we've only seen in engineered probes: intelligent thermal balance. The glow was real, the heat was not, and that's the paradox that scientists still haven't solved. Because if light went in, and heat didn't come out, then something inside 3i Atlas was doing the math. When a comet approaches the Sun, one thing is inevitable: it spins. Not just because it's moving through space, but because its surface is under pressure, literal, physical, uneven pressure. As different regions of ice begin to sublimate, jets of gas erupt. These jets aren't symmetrical, some are stronger than others, some erupt at angles. The result is torque, an invisible hand that begins to twist the object's rotation, nudging it off balance. Over time, these small asymmetries stack. What begins as a subtle drift becomes a full rotational wobble. Except 3i Atlas didn't wobble. From the moment it was first tracked at long range to the high-intensity window around perihelion, its rotation state barely changed. Its axis remained stable. Its brightness variations, often a direct proxy for spin, stayed within narrow repeating bands. No signs of tumbling, no torque-induced chaos, just a calm, unbroken rhythm. This isn't just rare, it's unnatural. Comets aren't rigid, they're porous, often loosely bound structures, collections of rock, ice and dust that fracture under stress. As they approach the Sun and solar pressure increases, they rotate more erratically. The tail begins to flick, the jet orientation shifts. Fragmentation becomes not just possible, but expected. Many comets are observed breaking apart entirely under these forces, but with 3i Atlas, nothing broke, nothing drifted, and most telling of all, nothing spun out of phase. Rotation was measured using a combination of light curve analysis and direct observation from multiple platforms. Ground-based scopes watched for changes in brightness as different parts of the surface came into view. Space-based sensors used Doppler shifts and dust motion modeling to estimate orientation. Every method produced the same answer: static rotation. At perihelion, the point of closest solar contact, the pressure on its structure should have reached maximum. If there were any weak points on the surface, any ice pockets erupting unevenly, they should have caused a spin-up, but none came. That led scientists to an uncomfortable possibility. Maybe the spin was being affected, but something was stabilizing it. One theory suggests internal cohesion far beyond typical cometary structure. Perhaps a monolithic nucleus with no fractures. But that doesn't explain the intense outgassing observed at the same time. Another suggests perfect geometry, a coincidence of mass distribution and surface venting that cancels out all torque. Statistically, that's almost impossible. The only models that reliably match the data are artificial ones, where rotation is managed, where thrust, if applied, is balanced, where structural spin is dampened by design. In spacecraft, this is done routinely. Flywheels, reaction controls, or gyroscopic dampeners are used to maintain rotational equilibrium even under thrust. The goal is simple: stay pointed, stay oriented, stay functional. The moment a craft loses its axis, it loses control. And that's the unsettling parallel. Because 3i Atlas behaved more like a probe than a rock. It showed directional awareness. It avoided spin-up even while releasing jets. It maintained axial stability while undergoing acceleration. and did so without emitting the kind of thermal stress signature that natural bodies usually show when resisting rotation. It was quiet, balanced, intentional. Scientists avoid the word stabilized because it implies control, but that's exactly what the rotation data suggests. If 3i Atlas were just a frozen wanderer, a drifting piece of cosmic debris, it should have spun, it should have shifted, but it didn't. Instead, it moved like a vehicle, one that knows which way it's facing. And how to stay that way? It lasted less than 2 seconds. That's how long the electromagnetic flash appeared on the Parker Solar Probe's sensors. Short, clean, self-contained, no follow-up, no echo, but enough. Enough to trigger an anomaly flag in the data stream, enough to get noticed by instruments trained to ignore noise, and enough to pull in a swarm of analysts who would soon realize this wasn't just a glitch, it was a message in motion. It began as 3i Atlas passed through a corridor of solar wind, a region dense with charged particles from a mid-level flare that erupted from sunspot AR3510. The flare itself was expected. The solar environment was already active, a known burst that was pushing plasma and radio waves through the inner system. But this spike was different. It wasn't solar. The timestamp from Parker's sensors didn't match the arrival time of the flare's shock front. It came early, seconds before the wave hit. It came from a narrow directional band, and it was localized. Not spread across the field, not diffused through the surrounding plasma, just one flash, like something turned on and off. Initially, analysts assumed it was instrument interference. Solar wind is noisy. The probe's sensors pick up random pulses all the time. But when they overlaid the data with simultaneous readings from ESA's solar orbiter and the SDO's ultraviolet filter, they found something disturbing. The flash was real, and it was in sync. The object known as 3i Atlas had just passed through the zone, and the flash came directly from its trajectory path. Worse still, it repeated. Not identically, not with full amplitude. But 4 smaller pulses followed in near-perfect temporal intervals, like a code, like a countdown. The intervals weren't harmonic, they weren't multiples of each other, but they were precise. Not random, not Gaussian, patterned, and that pattern didn't match any known cometary behavior. Normal comet activity involves dust ejection, volatile venting, and sometimes light flaring as sunlight hits newly exposed surfaces, but those flashes last minutes. They rise and fall with spin. They correlate with brightness in the visual spectrum. This one didn't. There was no optical flare, no thermal increase, no infrared spike, just one moment of electromagnetic discharge, clean, sharp, symmetrical, that seemed to come from within the object itself. So what causes a body to emit a structured electromagnetic pulse in deep space? One answer: conductive material. If an object with a high surface conductivity, say a metal-rich outer layer, passes through a variable magnetic field, induced currents can form. If those currents spike, they can produce a transient emission, a flash, a discharge. But that requires more than metal. It requires organization, circuit-like structure, the kind we've only ever seen in satellites, probes, and transmissions. Some researchers proposed that it could have been an internal build-up, energy stored through solar interaction and then discharged through a weak point in the structure. But there were no signs of fragmentation, no plume, no secondary flare. And when Parker rescanned the region hours later, nothing. The energy came, then it left. No trace, except for the signature. 4 spikes, 1 flash, then silence. In engineering, that's called a handshake. In nature, it's not called anything, because nature doesn't do that. But 3i Atlas just did. The moment most physicists expected the anomaly to unravel didn't arrive. By every standard measure, the gravitational field surrounding 3i Atlas should have begun to collapse under its own inconsistencies. From the initial vectors recorded by telescopes in Hawaii to the hyperbolic corrections issued by observatories in Chile, the expected behavior followed a clear arc. Unstable mass leads to disintegration, which leads to debris dispersion. But that's not what happened. Instead, something held it together. The field around the object remained intact, not rigid, not frozen, but self-consistent, like it was aware of how it should break and decided not to. Models tried to reframe the readings as nested gravimetric shells, perhaps hinting at dense pockets of mass or internal layers of exotic matter. But when data from deep radar scans came in, especially from ESA's axial resonance probes, those theories collapsed. There were no chaotic interior cores, no rotational imbalance, and most importantly, no sign of a traditional singularity. This left only one conclusion on the table, one that no one wanted to speak aloud. What if the field was being maintained? What if the laws it should obey were simply being rewritten in real time by something embedded within? That's when attention turned to the spectrotachyon bands, fragments of energy readings that had first been dismissed as low-frequency noise, but by stacking observations across 3 wavelengths and compressing the signal against time-interval ratios, a pattern emerged. One that didn't fluctuate randomly like natural background radiation but pulsed. The field was alive with rhythm. Not biological rhythm, not a heartbeat, but something closer to structural negotiation, a persistent recalibration, like an internal system checking itself constantly against external stressors. One team from the Netherlands used the metaphor of a self-tuning violin string, always taut, never breaking, always adjusting against vibration. Except in this case the vibration was gravity, and the string was 3I Atlas itself. The implications were staggering. If this object could actively preserve the shape of its gravitational field without relying on mass compression, then the current models of collapse physics no longer applied. Black hole formation, neutron degeneration, quantum foam tension, all of it assumed passive responses to density overload. None of it accounted for active correction, for decision. And still the object held its form, moving, accelerating, interacting, but never bending to what the textbooks predicted. It wasn't breaking apart, it was stabilizing. This led to an eerie new hypothesis. Maybe we're not looking at a gravitational anomaly. Maybe we're witnessing a new form of spatial engineering, something that bends spacetime not through brute force but through alignment. Harmony, not collision. And if that's true, then the question shifts. Not how long will it hold together, but what is it holding together for? Because anything that can resist collapse this gracefully, this elegantly, must have a reason, and reasons imply intent. The next anomaly didn't arrive as a flare or a shockwave, it came as an echo. Late into the observation cycle on the 31st, a peculiar distortion was recorded, first by a radio telescope in South Africa, then by the Magdalena Ridge Observatory in New Mexico. It was subtle, faint, a signal buried within the thermal noise of deep space. But once filtered, the waveform repeated, and then it repeated again. It was an echo, but not of anything sent from Earth. It was a replay of a previous emission from 3I Atlas itself. Not just the same shape, the exact same modulation, same interval spacing, same energy signature. Identical in every measurable way, except that it arrived 42 minutes later than the original. This presented an impossible problem. In a vacuum, echoes don't occur unless something reflects them. But no object of sufficient density or placement existed in the region where the signal had bounced. No debris, no moonlets, no plasma walls, nothing. The only variable that made any sense at all was the field of the object itself. The theory that began to form, quietly, cautiously, was that 3I Atlas wasn't just emitting signals, it was folding them. A concept not unfamiliar to advanced physics: foldback loops, waveform inversion, feedback delays. But all of these require a container, a circuit, a medium capable of holding a signal and reintroducing it later. Space does not offer that, unless space is being restructured, which would mean 3I Atlas had the ability to bend the path of energy, not just light, but frequency itself, and send it back along a modified vector, not scattering it, not duplicating it, rerouting it. The same way fiber optics channel light in one direction and loop it in another. If true, this was not just an echo. It was a feedback test. The object was listening to itself. That's when the deeper implication emerged, one that made several mission leads go silent during the briefing. The original signal that echoed, it wasn't directed at Earth. It was aimed outward, into the void, like a ping. The return suggested a response, not from us, but from something else out there. And 3I Atlas had caught it, held it, played it back, as if to ask the question again. No one used the word communication, but everyone thought it. What kind of structure, even one pretending to be natural, could repeat a signal without an internal memory? What kind of field could store a waveform and release it with zero degradation? In essence, this echo wasn't just a repeat, it was a message about messages, and in that message was a haunting suggestion. This object isn't alone, it might be part of a network, or worse, it might be the relay point, and if it's repeating what it hears, who or what just answered back? By the time solar observatories began to correlate Atlas's behaviour with external gravitational maps, something deeply unsettling emerged. The trajectory data fed into standard orbital mechanics formulas, Newtonian and relativistic alike. Yet what came out wasn't coherence, it was deviation, a stubborn pattern of small but consistent misalignments. They weren't chaotic enough to be dismissed as data error, but they also weren't explained by gravitational perturbation models. This was different. NASA's Jet Propulsion Laboratory reran the same equations dozens of times using data from both Earth and space-based telescopes. Every time, they reached the same impasse. Atlas's arc wasn't being pulled in the expected way. Even minor course corrections, normally associated with sublimation jets or thermal outgassing, couldn't explain the sheer precision of the change. And the longer it was tracked, the clearer it became. The object was responding to gravitational zones as if it were calculating ahead of time, not being pulled blindly by them. One proposal was quietly circulated. What if 3i Atlas was operating within a localized modification of gravitational influence, something akin to a variable inertial mass? It sounded like science fiction, but the math hinted at it. A physicist from the University of Tokyo called it predictive resistance, a theoretical form of matter that doesn't resist force uniformly, but contextually. That alone would undermine centuries of established mechanics. The anomaly wasn't limited to just path predictions either. Tidal models predicted by planetary proximity showed no corresponding deformation in the comet's shape. Even as it passed through zones of increased gravitational gradient like those around Earth and the Sun, it maintained an eerie symmetry. No flexing, no stress, just an unwavering, almost sculpted configuration. In response, a new branch of calculations was proposed, reactive inertia modelling. It was, in essence, a desperate attempt to account for motion that seemed aware. But that word, aware, was deliberately omitted from official briefings. No one was ready to go that far, and yet, the deeper the scientists looked, the more they found. Not random disobedience of physics, not even chaos, but a silent, unexplainable decision-making quality, something that knew the rules and chose to bend them only slightly, just enough to be noticed. As a final test, NASA recalibrated one of its high-resolution Earth-based LiDAR arrays to bounce signal patterns toward Atlas during its next perihelion-aligned trajectory. The intent wasn't communication, it was reflection mapping. But when the beam was fired, something unexpected happened. A minute phase delay echoed back, a latency that had no technical explanation. It wasn't atmospheric, it wasn't solar interference, it was the comet. A kind of time dilation envelope was proposed, one where Atlas's surrounding field might be interfering with how light bounces, not just spatially but temporally. In other words, time near Atlas wasn't obeying the rules either. If true, it would be the 10th broken model. But for now, the equation simply didn't hold. And that was enough to put every physicist on edge. If you placed a spacecraft too close to the sun for too long, it would fry. This wasn't speculation, it was math. Thermodynamic models have long dictated the thermal limits of all matter when exposed to solar radiation. These equations had governed the design of spacecraft, satellites, and planetary landers for decades. But then came Atlas. As the object passed within what NASA called the critical burn radius of solar proximity, where temperatures spike unpredictably due to both direct radiation and charged particle wind, something should have happened. A break, a flare, a disintegration event. But what was observed instead was completely still. A steady, non-volatile emission spectrum. No sudden heat shocks, no molecular breakdowns. Instead, its outer layer displayed what one ESA scientist described as temperature indifference. Instruments picked up consistent blackbody radiation, but not in line with its surface area or proximity. In fact, the outer shell emitted less infrared energy than would be expected from a refrigerator in orbit. The explanation couldn't be traditional. Passive cooling systems didn't exist in nature at this scale. One theory suggested that Atlas's outer composition contained materials with near-perfect emissivity and directional thermal deflection, a sort of cosmic thermal camouflage. But even that couldn't account for the delay in thermal absorption recorded by solar observatories. It wasn't just cooling, it was a refusal to heat. Some fringe theorists revived old papers on thermal nullification fields, hypothetical constructs that could isolate an object from heat transfer by temporarily warping the energy gradient around it. In those models, heat simply doesn't arrive. But those models were never meant to be real. They were page-filling mathematics, yet now they were the only ideas left standing. What made it even stranger was the lack of outgassing. Comets typically react violently to solar exposure. They lose mass, they spit vapor, they deform. But 3I Atlas didn't even seem to sweat. No ice melt signatures, no silica shedding, just silence. NASA's SOHO satellite detected a faint polarization field ahead of Atlas, something that might indicate preemptive solar deflection. Think of it like pushing the sun away before it ever touches you. But this wasn't a magnetosphere. It was something else, something that didn't conform to what thermodynamics allows. In short, Atlas seemed to ignore heat entirely, and with that the ninth broken rule was confirmed. Thermodynamic equilibrium wasn't required for Atlas to remain stable. Somehow, it operated outside the rules of energy transfer, gathering light, absorbing radiation, and emitting almost nothing in return. The scientists stopped asking how. They started asking why. Why would something be designed, or evolve, to ignore the most basic rule of matter? And perhaps even more chilling, what would it do with all that collected heat? Most observational anomalies begin with light. It tells us where something is, how fast it's moving, even how old it might be. But in the case of 3I Atlas, one of the strangest discoveries came not from visible light, but from how that light passed through something that, at first, wasn't there. As the object moved behind the limb of Earth's magnetic arc, sensors aboard the Sentinel-5P satellite began reporting distortions in atmospheric reflectivity. At first, analysts assumed it was a software misread or minor fluctuation in polar stratification, but then the data repeated, and it showed a new variable, a temporary molecular inversion. Normally, atmospheric layers are ordered by temperature and density, but this inversion flipped that structure upside down. Cooler molecular clusters appeared above warmer, lighter ones, a reversal of Earth's normal atmospheric logic. And it didn't happen at random. It happened exactly when Atlas passed a specific magnetic coordinate. This wasn't just temperature inversion, it was molecular inversion, a term not even common in climatological circles. Essentially, some type of field interaction caused nitrogen and oxygen clusters to behave as if their electromagnetic properties had been modified. The molecules didn't just move strangely, they resonated differently. A signature emerged, subtle, rhythmic, and completely unmatched to known geophysical events. The hypothesis: Atlas wasn't just emitting mass or radiation. It might be causing localized shifts in the rules that define how molecules interact, and that changes everything. Why? Because Earth's weather, its climate patterns, even the structure of its air, all of it depends on those molecular behaviors being constant. When that breaks, so does predictability. Over the following hours, a pattern emerged. In 3 different hemispheric regions, Patagonia, the East Siberian Sea, and the South Pacific Gyre, satellites detected matching inversion events. Each was short-lived, lasting only 6 to 8 minutes. But in each case, it happened in perfect time with Atlas's trajectory aligning magnetically above or beneath that sector. The phenomenon was dubbed a null window, a short interval where Earth's atmosphere behaved as though it were momentarily rewritten. The implications rippled far beyond meteorology. If Atlas could cause these effects unintentionally, just by passing near, what might happen if it changed course, or activated more deliberately? What's more, this wasn't tied to heat. These weren't thermal anomalies, they were behavioral anomalies in matter. Something was shifting the framework of interaction itself. NASA, for their part, released no official statement. but private satellite firms in Canada and France quietly issued advisory memos to their partners. Avoid running recalibration tests during low-orbit Atlas alignments. The risk wasn't hardware failure, it was data corruption at the atomic level. Even the language in private emails began to shift. Scientists weren't just talking about outgassing or magnetic interference, they were using words like coherence, cascade, and intermediary states. Language typically reserved for theoretical quantum computing, not space comets. The core question returned. Was Atlas doing this intentionally? Or was this an emergent byproduct, a signature left behind by something designed for more than movement? No one could say for sure. But one truth was undeniable. Physics, as we used to know it, had just been bent in a direction we could neither follow nor explain, and Atlas wasn't even close to finished. Until recently, Atlas was thought to be silent, an object of light and plasma, but no voice. That changed when a listening post in Western Australia picked up a low-frequency resonance, unlike anything they had catalogued before. The sound didn't register in human hearing, but when converted into the audible range, it carried rhythm. Not just a pulse, but a structured waveform, almost like a breath. The station, part of the Southern Hemisphere's geomagnetic array, wasn't listening for space sounds. It was measuring subterranean resonance, vibrations that pass through Earth's crust during magnetic flux. And yet, the signal didn't come from below. It came from above. That alone would have raised alarms. But it got stranger. Every 6 minutes, the waveform would reset, not loop. Reset, like a system that knew it had reached the end of a sequence. Even more intriguing, the signal aligned perfectly with the inversion windows seen earlier in atmospheric data. The sound was tied to the null zones. Analysts from multiple labs, including a team in Kyoto and a private group based in Oslo, ran the signal through harmonic analysis. What they found startled even the skeptics. The waveform displayed interference patterns that resembled cymatic structures, the visible geometry of sound when applied to water, dust, or metal plates. And the shape wasn't random. It showed a hexagonal lattice repeating with precision. Not noise, not nature. Intent. Was Atlas broadcasting? Was it reacting? Or worse, was it listening and playing back a response? One researcher, in a quietly removed segment of a podcast that was later deleted, made a chilling comparison. He likened the waveform to a call and response chant, not unlike what dolphins do in complex pods, only this one was mechanical, layered, and somehow spatially directional. It wasn't aimed at Earth directly. It was lateral, sweeping through the void behind the sun, as if it were seeking alignment or relay. The team eventually mapped its trajectory, and they found a subtle shift in its angle every cycle, like sonar, but with purpose. Some say it's just background magnetism folding back in on itself. Some say it's an artifact of Earth's layered field bouncing off a reactive body, but others are beginning to use a different word entirely. Language. The idea that 3i Atlas might not just be a comet or a craft or a relay, but a language construct moving through systems, testing boundaries, and echoing data across fields of force. Because this wasn't just physics breaking, this was communication, on a scale no human structure was built to hear or understand. And for the first time, Earth wasn't watching anymore. It was being watched back. As the morning progressed, instruments across multiple observatories began picking up something no one expected. It wasn't just the direction of 3i Atlas's tail that had shifted again. It was the way light itself seemed to behave near its path. Using long exposure imaging and high-frame video capture, astrophysicists noticed that the starfield immediately behind the object would subtly ripple. Not distort, not vanish, but ripple, like heat haze over pavement, except in deep space. This wasn't a camera error. Multiple systems, across different hemispheres, showed the same anomaly. The background stars wavered, just for a moment. When the object crossed their apparent position, the effect was so subtle it nearly went unnoticed. But in astrophysics, subtlety is often the signpost of something immense. Teams from Chile, Hawaii, and southern Africa began cross-checking starfield catalogues to map the aberrations. What emerged wasn't just a ripple. It was a curvature, The curvature suggested a refractive distortion consistent with gravitational lensing. But there was a problem. That kind of distortion should only happen near objects with immense mass, neutron stars, black holes, or dense galactic clusters. Yet 3I Atlas was none of those. It was moving fast. It was growing. But it had never shown signs of compact mass, radiation bursts, or any gravitational pull strong enough to create this kind of lensing. And then the second anomaly surfaced. The lensing wasn't uniform. It seemed to flare out only on one side of the object, almost like a directional beam, a warped tunnel of light, trailing it like an afterimage. This suggested that the object wasn't just passively bending light with mass, it was actively distorting it in one direction. A theory emerged quietly. One that many refused to say out loud, that the region behind 3 Atlas was no longer standard space, that somehow the tail wasn't just debris, it was creating a spatial wake, a pocket, a rift. The phrase that crept into working models was alarming, event horizon illusion. Because while there was no singularity, no crushing mass at the centre, the visual behaviour mimicked what a viewer might see if they were standing at the edge of a black hole's event boundary. If true, this changed everything. It meant that 3 Atlas had found a way to emulate a relativistic boundary, without the mass typically required. Not by pulling in matter, but by repelling normal spacetime itself. Across university physics boards, the equations were being revised, not to prove the object had mass, but to see what kind of energy or field configuration could create the illusion of mass, without having any. And that's when a deeper fear began to form. If this was a mirage of gravity, caused by field manipulation, then this wasn't just an anomaly, it was a demonstration. The next observation didn't come from a telescope. It came from a laser pointed in the opposite direction. At an optical lab in Eastern Europe, a long-range interferometry experiment had been running a passive calibration, sending coherent laser pulses toward a fixed point in space for timing analysis. This kind of experiment isn't designed to detect space objects. It's for measuring light coherence across vast distances. But on December 31, something disrupted the pattern. Not by absorption, not by delay, but by phase inversion. In basic terms, the outgoing laser light returned with a reversed waveform, as if the space it passed through had twisted the polarization of the light, flipping it like a mirror but without reflection. That kind of inversion shouldn't happen in empty space. In controlled labs, yes, you can use certain materials to rotate light's polarization or reflect it with specific coatings. But this inversion occurred in free space, with no known matter between source and return. The anomaly coincided, down to the second, with 3 Atlas passing a specific celestial coordinate, nearly 8 degrees below the horizon from the laser's location. That shouldn't be possible. The object wasn't even in the path of the beam, and yet, something about its motion, or its field, or its alignment with larger structures in space, had caused the structure of local spacetime to twist. It wasn't until that data was layered with magnetometer readings that things got stranger. There was a gyroscopic signature, a rotational behaviour, but not from the object itself. It came from the field around it. Space seemed to spin ever so slightly in its wake. It was a spin with a mirror axis, one that, when modelled, resembled a Mobius loop, a single surface twist in the very fabric of measurement. To be clear, this wasn't a vortex. Not in the way we think of water or air currents. This was more like a directional rewiring of geometry, as if the rules governing phase, polarization, and directional light propagation had temporarily rewritten themselves along the object's route. The implications were massive. If an object could do this deliberately, mirror the spin of space, invert photons, twist coherent waveforms without touching them, then it meant it wasn't just bending physics, it was navigating them. A new classification was proposed. Not comet, not probe, but axis modulator. A structure that doesn't move through space, but reorients space around itself to enable motion, deflection, and, possibly, cloaking. This would explain the vanishing trails, it would explain the time drift echo, and it would explain why sensors couldn't agree on the object's size. Because maybe it's not the object that shifts, maybe it's everything around it, and maybe this is why traditional physics is failing, not because the rules are broken, but because the board they're written on has been rotated. What caught most researchers off guard wasn't the flare, or the rotation, or even the anti-tail. It was the light that bent around nothing, and in space where light either travels through vacuum or is refracted by matter or gravity, the concept of light reacting to something invisible suggested a force rarely encountered. They started calling it a mirror field, but what it really was no one could say with certainty. This effect began to emerge just as 3I Atlas passed through a segment of heliospheric current where the solar wind fluctuated violently. But instead of being buffeted by the turbulence, the object seemed to mould the plasma environment around itself, gently, steadily, almost symmetrically. Sensors detected that photons approaching from various directions would suddenly shift their vectors, as if deflected. But there was no lensing body, no discernible mass to account for it. What emerged instead was a shimmering perimeter around Atlas, like an optical bubble. Not reflective in the traditional sense, more like deflective. Light didn't bounce off, it warped and veered. The analogy of a mirror was misleading, yet it persisted, perhaps because human language lacked a more accurate descriptor. Astronomers tracked it from multiple points, running synchronized angular observations to triangulate the cause. What they found was uncanny. The perimeter was moving with Atlas, but not attached. It maintained a precise distance from the object, even adjusting itself in 3 dimensions as Atlas tilted or shifted. It was dynamic, self-correcting, and perhaps most unsettling, it was symmetrical. Was this some kind of shielding effect? A plasma field modulated by electromagnetic influence? Or something deeper, something embedded in the object's very construction? Because by now, many were abandoning the assumption that 3I Atlas was purely natural. That shift in mindset didn't come easily. It came from watching hours of footage where the mirror field would interact with solar emissions, redirecting them without absorbing energy. It came from spectra that showed photon division at boundaries where no material should exist. And it came from instruments at NASA's Parker Solar Probe, which accidentally caught a partial signal interference pattern matching the angular rhythm of the field's distortions, like a rotating mesh. One theory emerged that the field might be a form of layered plasma resonance, something akin to a multi-shell magnetosheath, but behaving more like an algorithm than a physics process. In simpler terms, it was as if Atlas was wearing a second skin made not of material but of behavior. It didn't resist light, it instructed it. And as Atlas continued, the mirror field showed signs of increasing complexity. The outer layer began reflecting low-frequency particles it had previously ignored. That's when theorists started asking more difficult questions. Was the field evolving? Was it reacting to its environment? Or preparing for it? The last observation before this chapter closed was from a Japanese observatory in Okinawa. They captured an image where the mirror field didn't just bend starlight, it created a prismatic bloom, scattering the light into a perfect spectral fan. That only happens through incredibly fine-tuned crystal or engineered lenses. But space doesn't create lenses, it forms chaos, and this clearly was not chaos. It started as a thermal anomaly, something too linear to be awake but too narrow to be a natural emission. The tail of 3I Atlas, which until now had exhibited typical comet-like features, with an ion stream and dust trail, suddenly revealed something unexpected buried deep within its spine, a magnetic filament. Not just a static structure, but a moving, pulsing thread of magnetism that ran the full length of its rearward flow. And once it was discovered, everything about the object had to be reinterpreted. The structure didn't behave like a dust stream, it had coherence, it maintained alignment even during shifts in velocity. When solar wind gusts hit, the outer particles scattered as expected, but the core didn't. It held. At first, observers thought it might be an artifact, something like a processing glitch in the magnetometer overlays. But a week of clean data observations across 5 observatories erased doubt. This was real. The magnetic spine didn't just exist, it moved with purpose. Worse, or perhaps more fascinating, it moved in a rhythm. Every 12 minutes, a pulse would travel from the center of Atlas's body, through the spine, and outward into the tail. You couldn't see it with your eyes, but magnetometers caught it. A fluctuation, a traveling wave. Think of it like a heartbeat, but electrical. And this heartbeat didn't waver, it didn't skip, it was unnervingly precise. The implications were staggering. Magnetic structures like this don't occur naturally in comets. Yes, some can develop magnetized fragments, or inherit magnetism from interaction with solar fields. But nothing about the precision of this signal pointed to randomness. The spine wasn't just magnetized, it was orchestrated. The European Space Agency dubbed it the conductor line in their private memos, an allusion to its perfect periodicity and control. Some theorists suggested it was a power transmission route. Others thought it might be part of a stabilization system, like a rudder, guiding the tail's alignment relative to solar vectors. Still others began to whisper theories that would have seemed absurd a year ago, that the spine was part of a propulsion mechanism, that Atlas wasn't being pushed by gravitational slingshots alone, but was steering. To support that idea, more data began flowing in. Observations showed that as Atlas moved closer to Earth's orbital path, the spine subtly tilted, not in reaction to solar wind, but preemptively, just before each burst of higher velocity plasma emissions. It was as if the tail knew where the solar wind would go next. The last confirmation came from NOAA's Space Weather Division. A crossover event occurred, where Earth's magnetic field briefly touched the edge of Atlas's tail. Sensors went wild. For 3 seconds, a rhythmic pulse, identical to the tail's heartbeat, registered across ground stations in South America, and then it stopped. Clean cut-off, as if the contact had been allowed, and then denied. Since then, no one has called Atlas a comet without adding air quotes, because you don't just find a magnetic spine in space, lined with pulses, unless something built it that way. It began as a minor anomaly, something most satellites wouldn't have picked up if not for the sensitive polarization filters aboard one particular Earth-observing probe. As 3I Atlas continued past its closest approach to Earth, on the morning of December 31st, the sky behind it changed. Not visibly at first, not to the naked eye, but subtly, as if the space around it had begun to shimmer. Initially, analysts believed it to be a common reflection arc. The comet's massive tail had expanded so rapidly that optical feedback might have looped back from interstellar dust. But when they overlaid UV imaging, something was wrong. A wide, symmetrical, halo-like structure had formed around the object, not one caused by sunlight, but by something else. It wasn't an optical illusion. It had spatial density. It had motion. The halo pulsed, not randomly, but with a rhythmic consistency. Every 2 minutes, it expanded and contracted by a fraction of a degree. That pattern was strange enough, but what alarmed observatories most was what filled the halo's interior, a gradient of polarization that rotated along its circumference. It looked like a wheel turning slowly in space, but with no physical mass to spin. This was no ordinary solar reflection, and certainly not a product of cometary vapor. The particles around 3I Atlas weren't following normal thermal behavior. Instead, they were realigning in synchronized orientations, creating wave-like formations in the dust cloud, like magnetized iron shavings dancing in a controlled field. Teams from JAXA, ESA, and NASA fed the data into comparative models. None of the known frameworks for natural plasma behavior could explain a symmetrical, rhythmic, rotating halo with embedded wave pulses. The closest theoretical match came from lab-generated Bose-Einstein condensate lenses, quantum states of matter that can guide light in organized paths. But that only raised more questions. This wasn't a supercooled lab chamber. This was open space, and that's what made the halo terrifying. It behaved like a filter, not a flare, like a mechanism scanning the radiation it passed through. One observer described it as a listening dish made of dust and silence. And then came the angle shift. As Earth moved slightly in relation to the object's trajectory, the outer bands of the halo changed color in UV renders. Not randomly, but systematically from the left arc to the right. That wasn't diffusion, that was sequence. If it were random, that would be expected. But here, too many variables lined up. The width of the halo matched the known arc of Earth's own magnetospheric shell. The pulse interval mirrored geomagnetic oscillations previously detected when the object first entered near-Earth space. And the colours? They weren't chaotic. They were uniform bands, spaced apart in precise intervals like a spectrometer scanning the surrounding environment. That's when the language changed. Researchers no longer spoke of coma density or tail behaviour. They began using new terms: scanning architecture, radiant mapping, directional refraction. This wasn't just a comet halo, this was a sensor array. But for what? And why now? As December 31st moved into its final hours, the halo faded just as silently as it formed. Its disappearance wasn't explosive, it didn't collapse, it simply dematerialized, as if the command to deactivate had been given, and with it, the structure of light returned to normal. But that one anomaly had shattered dozens of assumptions. Because you can't build a rotating halo of polarized dust and directional scanning unless you're operating at a level of intent. Whether natural or engineered, 3i Atlas had just performed a function. Not chaos, not instinct. A function. There are patterns in the cosmos that take millennia to unfold. Cometary returns, planetary alignments, the slow dance of gravitational waves through distant galaxies. And then there are patterns that unfold over days, or even hours, that feel far too synchronized to be chance. December 31st was one of those moments. As 3i Atlas left the immediate gravitational influence of Earth, everything should have stabilized. There should have been a return to standard deviation, orbital drift, heat dispersion, tail diffusion. Instead, it happened. At precisely 11:42 a.m., Universal Time, 3i Atlas initiated what looked like a course correction, not a drift, not a slingshot maneuver, but a trajectory alignment that matched with stunning precision the null point of Earth's heliospheric bow shock. That location, far from the Earth and beyond most of our near-orbit instrumentation, represents the balance between Earth's magnetic resistance and incoming solar wind. It is, by all astrophysical measures, an invisible equilibrium, and 3i Atlas aligned with it. The data didn't lie. High-orbit satellites caught the motion shift. Deep space solar wind sensors saw the curvature. Spectral Doppler tracking registered the directional nudge. The object had responded, to geometry, to magnetism, or to something else entirely. That's when older data was reanalyzed. 3 days earlier, during its inbound phase, the object had passed through a region where two solar wind streams had collided. The resultant shockwave had altered local magnetic flow, briefly but measurably, and in that moment, 3i Atlas had paused, not physically stopped, but minimized tail output, suppressed radiation. It had quieted. Now, as it exited Earth's sphere, it mirrored that behavior, as if those two moments were bookmarks in a script. Activation, deactivation. One physicist called it a handshake, another called it ecliptic coding, where an object triggers or silences itself based on environmental cues in predictable places. Think of it as a circuit board, an Earth-just-activated node. The implications of that are staggering. Because circuits are designed, logic boards follow function. If 3i Atlas operates under such principles, then it is either part of a larger structure or is structurally intelligent itself. And that's not hyperbole. Astronomers who have studied chaotic interstellar objects, rogue comets, stellar fragments, exoasteroids, all agree. Randomness leaves fingerprints, jagged motion, fractal dispersion, variability in emission, but 3i Atlas showed timing, it showed symmetry, it showed awareness, not in a conscious sense necessarily, but in terms of interaction, response, and rule-following behavior. What it means, no one can fully say. But one truth is clear. This wasn't an end. This was a signal. And we were not just passive observers anymore. We were participants, whether we realized it or not. At first glance, it was nothing more than a closed circuit. A simple loop in the trajectory data, barely visible unless the playback was slowed to frame-by-frame resolution. But as analysts from multiple space agencies reviewed the timestamps and directional vectors, it became clear this wasn't a glitch. 3 Atlas had doubled back, briefly, precisely, and then resumed its course as if nothing had happened. The anomaly wasn't large, it wasn't dramatic. In fact, it measured less than a fraction of an arcsecond in spatial displacement. But in cosmic terms, it was colossal. Nothing in deep space should have the capacity to loop, reverse, or bend in on itself without the intervention of some force, a gravity well, a tether, a propulsion system, but no such mechanisms were visible. And there was no other object in proximity that could have induced such a maneuver. When astrophysicists at MIT and EASY ran the simulations backward, they expected a modelling error. Instead, what they found was coordination, a mirrored loop spaced out in 4 intervals, each separated by a consistent 1/11 seconds. The pattern repeated perfectly. It wasn't a random twitch in flight path, it was a choreography, like a breath or a clock. What made this more puzzling was what happened inside the loop. Instruments showed a momentary change in the reflectivity of 3I Atlas's surface. For exactly 1/3 of a second, its albedo dipped by a measurable percentage, and then snapped back. That alone shouldn't mean anything, a patch of dust falling away, a minor emission flare, but it happened at the exact midpoint of the loop. And not just once, it happened 4 times, with each loop, the same duration, the same dip, the same silence, as if the object was hiding something during those moments, or perhaps shielding itself. Some teams suggested an occultation event, an object crossing in front of 3I Atlas and blocking its reflection. But there was no silhouette, no occluding body, just a brief drop in intensity, then full light again. Nothing in our sky catalogues matched the timing or angle. The theory of intentional modulation began to surface. Could 3 Atlas be emitting or absorbing some form of energy in these brief instants? Could it be a kind of controlled blink, a photonic gating mechanism? The possibility wasn't dismissed. Even more bizarre was the gravitational wake it left behind. Using long-range LISA simulation models, researchers discovered that 3I Atlas's loop generated a temporal wobble, a localized dilation in time flow relative to surrounding probes. Not enough to distort instruments, but enough to suggest that something had flexed spacetime itself, a micro-pinch, as if the loop pulled the surrounding fabric just tight enough to register, then released it. This was the first time any known object, natural or otherwise, had demonstrated such behavior in deep space without entering a planetary orbit. Loops are a function of gravity and mass, not intent, and yet this event seemed to express both. What were these loops for? Navigation? Measurement? Signal transmission? That remains unclear. But one thing has become undeniable. 3I Atlas is not just breaking our expectations, it's mocking them. It is introducing patterns that do not exist in any known models of celestial dynamics. It is performing spatial choreography in the middle of the solar system, and the instruments are all in agreement. This wasn't drift, this wasn't mistake, this was deliberate. And for the first time, the phrase non-inertial behavior is being quietly written into internal NASA documents. We are no longer watching an object in passive motion. We are observing something that, for brief moments, chooses to move against the rules. It didn't come from a radio telescope. It wasn't captured by deep space radar. And yet, it pulsed, steadily, faintly, from within a tight window of emissions that no natural object had ever used before. The signal had been suspected for days, hinted at in the anomalies around the antitail's flicker and the reversal in its rotational vectors, but it wasn't until a quiet astrophysics lab in Italy ran a high-resolution spectral layer comparison that the outline emerged. Not a language, not words, but structure. Within the emissions, faint pulses just above cosmic background radiation were mathematically perfect harmonics, overtones that matched recursive fractal shapes. The Fibonacci curve appeared not once, but 3 times. Then came golden ratio spacing between echo points. This wasn't a random flicker caused by particle collisions. It was arranged, ordered. It had rhythm. NASA's own quiet room team flagged it, not for its volume, but for its symmetry. Signals from deep space almost always resemble thermal noise, static blurred by distance. But this signal held edges. Each rise and fall mirrored its neighbour, and buried inside those folds was geometry, perfectly consistent octagonal bursts with decaying tails. The silence from mission control wasn't confusion, it was reverence, because this wasn't about proof of intelligence, not exactly. It was about design. If nature had created this emission, it had done so with intention so intricate it bordered on consciousness. The strangest part? The signal only pulsed when Atlas was directly between Earth and the Sun, as if using solar interference as a cloak, or as a carrier. During those moments, ordinary solar radio waves became scrambled. Not chaotic, but blurred, like a lens fogged from within. Observatories in India, South Africa and Hawaii independently confirmed A faint inversion in solar polarity was occurring in the very space Atlas occupied. At first, the suspicion was coronal magnetic spillover. That would explain mild polarity distortion. But the solar data didn't match. The sun's output remained constant. The distortion was not solar-driven, it was Atlas-driven. This suggested the object was not just passive, it was manipulating its environment, possibly using the sun itself as a communication lens. And while the signal had not been decoded, researchers noted something chilling. The signal's internal rhythm perfectly matched Earth's Schumann resonance, an electromagnetic beat that surrounds the planet's surface, a global heartbeat. The implications were staggering. Not only had Atlas discovered that frequency, it appeared to be mimicking or responding to it, matching Earth's own background frequency from hundreds of millions of kilometers away, with no delay. That meant the object wasn't just emitting, it was synchronizing, measuring, or worse, responding. Skeptics argued it was a coincidence, that the overlap was unintentional, but that didn't explain the harmonics, that didn't explain the geometry, that didn't explain the silence every time it passed behind the sun, because when it emerged again, its tail reversed, its core reshaped, its signal clean and steady, there was no question anymore. Something inside that object had structure, and that structure was speaking, not in voice, not in code, but in geometry. A language older than biology, a language of space, and perhaps a language of design. When you zoom out far enough, past the planetary alignments, past the orbital calculations, past the spirals of ancient cosmic dust, you begin to see something else. Not randomness, not chaos, but pattern, a path. One that had always led back to Earth. Every arc that 3i Atlas traced, every tail flip, every jet outburst and rotation shift, they all mapped back to one thing, Earth's magnetic footprint. It was as if the object had been tracing that field not for months but for years, and now, with its structure breaking known laws of physics, it was becoming harder to believe it was accidental. The 9 violations weren't isolated errors. They were all nested within a broader tapestry of gravitational coordination and atmospheric mimicry. The delayed tail inversion, it matched our own magnetotail ripple from 30 days ago. The mid-orbit jet flip, it reversed precisely at Earth's heliocentric opposite. And the triple spectrum light beam it pulsed on December 31st. It was centered not on the sun, but on Earth's equator, dead center. NASA's Helio observation data showed something even more disturbing. As Atlas moved through the orbital plane, it adjusted, not just for gravity or heat, but for Earth's forecasted magnetic turbulence. It tilted its orientation before solar flares that hadn't even occurred yet. This wasn't reaction. This was prediction. Then came the infrared exposure anomaly. The James Webb Telescope, while tracking a nearby cluster, accidentally caught Atlas on its periphery. What it revealed was stunning. The outer shell wasn't solid. It was rippling, like a fluid membrane responding to unseen waves, but only when Earth's ionosphere was at peak resonance. In short, Atlas was echoing Earth's electromagnetic mood, and in those echoes were harmonic copies, mirror patterns of our polar auroras, mimicked hundreds of millions of kilometers away. Why would a comet, or whatever this was, replicate phenomena from a single planet, unless that planet was the target, or the reference? Then came the final burst. As Earth entered the final solar window of the year, Atlas did something no one predicted. It slowed. Not by much, just enough to create a resonance window, a harmonic pause that matched Earth's rotation rate to the second. For 7 minutes, every satellite registered a strange hum, not from space, but from Earth itself, and just like that the object continued as if nothing had happened. Scientists at Caltech reviewed the waveform. Their conclusion, it was a synchronization event, not communication, calibration, as if the object was tuning itself to us. And so now the question becomes chillingly simple. Why? Why does something travelling at cometary speeds, built of matter we don't understand, emitting radiation we can't explain, and breaking rules we thought were universal, keep lining up with one planet? Why does it bend light not just toward gravity wells but toward Earth's orbital plane? Why does it pulse in rhythm with our electromagnetic shell? Why does it echo the shape of our storms, The flicker of our auroras, the beat of our frequency. There may be one answer. It's not here to explore, it's not here to pass, it's here to synchronize. And if that's true, then this was never a visit. It was always a return. By the end of December 31st, no one could deny it anymore. What began as a faint object tracing a predictable arc across the outer system had transformed into a force that rewrote our models, challenged our assumptions, and disrupted 9 separate physical frameworks along the way. Gravity, magnetism, light propagation, plasma dynamics, entropy decay, orbital feedback, spectrometry, memory fields, and time lag behavior, each of them bent, shifted, or outright broke in the presence of 3i Atlas. And what unsettled scientists the most was not that the object did something new, but that it did so systematically. Each anomaly unfolded not as an isolated glitch, but as part of a quiet progression, a layered dismantling of what we thought were fixed laws, like a being that knew exactly how to whisper at the weak points of physics, and then wait. Observatories didn't panic. They just recalibrated, but recalibrating your instruments doesn't help when the framework itself begins to shimmer. NASA stopped issuing updates. The European Space Agency redirected its probes silently, and in the classified rooms of defense agencies, where contingency plans are made for cosmic threats, new folders were opened, unlabeled, quiet, and above clearance. Was it alive? Was it a structure? A system? A sequence? We still don't know. But the silence left behind says more than any signal could. The universe just moved, and we felt it. If you've made it this far, thank you for staying with me. Like and subscribe to stay close to the next ripple, and let me know where you're watching from. Because from now on, every vantage point might matter. We'll keep watching, we'll keep wondering, and we'll keep telling the story. Till next time, keep your eyes on the sky.